help us learn about measurement. And one thing I'm going to point out here that's important, it says you can't cheat and record a better measurement than the instrument is capable of. And what they mean by that is a term that they're going to call like certainty. So question 1 says, what distances can you be certain of in Model 1? Here's 6 people's measurements. But if we look at this ruler, there's only 2 markings, 0 and 10. So unless an object is exactly at the 10, you can't be certain. If something's here, maybe that's 5, maybe it's 5.1, 5.09. Can't be certain because it's not labeled. So when they say what distances can you be certain of, it's only something that would be perfectly on a marked line. Number 2 says 6 students used this ruler. Here's their what they got. What do you think? Why do you think they got different measurements? Think back to what I said about number 1. It says, number 3, the ruler in Model 1 isn't very useful, but you can't estimate. How do you think they should have kind of divided this up? So like, how could they have a good estimate of where maybe 5 is, 2, 6, 8, any of those numbers? Here's another ruler. Same question, except a better ruler. What distances can you be certain of here? So answer that based on what we talked about above. Same kinds of questions here, except number 5, it says every student agreed on the single value, meaning this 3. Their decimals were different. We have 0.1, 0.2, 0.3, nothing, 0.25, 0.20. But why did they agree on that value is what this question is saying here. And then number 7, which ruler had more variation? So that means differences. And you'll look back to ruler B and ruler A and say which one has more differences. Ruler C is even better. It says which values and digits did they agree on here? So remember this, if they agree on this column, it would be the ones column, the tenths would be here, and the hundredths next to that, and the thousandths would be that third column. Number 9 says basically why is Model 3 ruler better? So here we go again. Read this little background. And we have ruler A, ruler B, ruler C put down here from above. And it says the valid measurements column, so we're talking here, has circles around estimated digits and squares around certain digits. In other words, a square, these means they're certain of it, and anything circled means it's an estimate. Remember, you can only be certain of things that are exactly on a number. Whether that's a decimal, like right here, you could be certain of that if something was here, or if it's on an exact number. Number 10 says highlight the best answer. In a valid measurement, remember, valid means squares. So if you look up here, look at this column. In a valid measurement, you record how many estimated digits, 0, 1, or 2. Estimated are circles. B, in a valid measurement, the estimated digit is where? Is it the first digit, the second, to the last, or the last? And in a valid measurement, again, our squares, where is the estimated digit? Is it the largest, smallest, or 1/10 of the smallest? Meaning, would it be the largest, the smallest, or the middle, the 1/10 of it? It says, in Model 4, Tony had a measurement of 3. Why is that invalid? So how could that be invalid if he had a measurement of 3? Make sure you look at the right graph and say which one it would have to be if it was invalid, meaning not sure. 12 says using ruler B from Model 4, Diane recorded a measurement of 3.2, which is invalid. Maya on the next ruler C had the same measurement, but it was valid. How can the ruler C with the same measurement 3.2 be considered legit and valid? Or certain, that might help you from before, versus ruler B. And a student recorded the length of a test tube as 5.0 centimeters. Which model would they have to use if this is valid? This gray section is going to be kind of extra. I forgot to type here for an A. So if you want to try it, great. If not, you can't get higher than a B.